Hi everyone, myself Venkata Divya, studying in Sri Venkateshwara College of Engineering, Bangalore, Department of CSE AI, 3rd SEM. Today in this video, I am going to tell you about the basic concepts of probability theory. First, I will give introduction about what do you mean by probability theory. Probability theory is a branch of mathematics that deals with the study of uncertainty and randomness. It provides a framework to analyze and quantify the likelihood of events occurring. The theory is essential in various fields such as statistics, economics, physics, and computer science. Probability theory is a branch of mathematics that deals with the analysis of random phenomena. The central objects of probability theory are variables, statistics, process, and events. The probability theory is a mathematics foundation and statistics. Now, in that probability, we do experiments and sample space. An experiment refers to any process that can produce a well-defined outcome. The set of possible outcomes of an experiment is called as a sample space. For example, when flipping a coin, the sample space consists of two outputs, like heads or tails. Sample space and probability. Now, sample space means probability experiment, a chance process that deals to a well-defined results are called as outcome. For example, flipping a coin. If we flip a coin, we will get the output as heads or tail. We have 50-50 chances. Outcome means the result of the single trial of a probability experiment. Now, events and probability. An event is a subset of sample space representing a particular outcome or a combination of outcomes. The probability of an event is a measure of how likely it is to occur and ranges from 0 to 1. A probability of 0 indicates impossibility, while a probability of 1 indicates certainty. Events and its probability. Definition means a subset of E outcomes is called as event E. Probability of event. The basic formula is a total number of outcomes in the event by total number of outcomes in the sample space. Here is the example you can understand. Probability axioms. The probability theory is based on three axioms. Non-negativity axiom states that the probability of any event is always greater than or equal to 0. Additivity axioms states that the probability of the union of two mutually exclusive events is equal to the sum of the individual probability. Complementary events and probability. The complement of event A, denoted by A bar or A dash, consists of all the outcomes in the sample space that are not in A. The probability of the complement of event A is equals to 1 minus the probability of the A. For example, if the probability of the rain is 0.3, the probability of no rain is 0.7. Here is the complementary event and its formulas. You can refer to it. Now, conditional probability. Conditional probability is the probability of an event occurring given that another event has already occurred. It is denoted by P of A of B, and calculated as the probability of intersection of A and B divided by probability of B. Conditional probability is essential in understanding dependent events and based on the Bayes theorem. Conditional probability is P of A of B equals to P of A intersection B by P of B. P of B or P of A intersection B means probability. Now, independent events. Two events A and B are independent if the occurrence of one event does not affect the probability of the other event. Mathematically, two events A and B are independent if A by probability of A by B is equals to probability of A, and probability of B by A equals to probability of B. The multiplication rule can be used to calculate the probability of intersection of two independent events. Probability of the independent events is if A and B are independent events, then the probability that both A and B occurs. Random variables. Random variables is a numerical value that takes on different values based on the outcome of a random experiment. There are two types of random variables, discrete and continuous. Discrete random variables can only take on a countable number of values, while continuous random variables can take on any values with a given range. Now, probability distribution. A probability distribution describes the probabilities of the different values that a random variable can take on. For discrete random variables, the probability distribution is often represented by probability mass function, which is also known as PMF. For the continuous random variables, the probability distribution is often represented by the probability density factor. Here is an example based on the probability distribution. Now, expected values and variance. The expected values of a random variable is the long-term average value it would take on if the experiment is repeated many times. It is calculated and the sum of each value is multiplied by its corresponding probability. The probability of a random variable measures the spread of or variability of its values around the expected value. If it quantifies how much the value deviates from the mean. Expected random variables means a random variable acts as a numerical value measure of the outcomes of the experiment. Thank you. I hope this video will be helpful for you. Please like, share and subscribe.